So we're going to establish whether this series is convergent or divergent. First of all, let's check quickly in our mind the test for divergence. So this is my an. Is the limit of an 0? Yes, clearly, because this is the ratio to polynomials and the degree of the denominator is greater than the degree of the numerator, so the limit is going to be 0. I'm not going to do the formal computations. I already know that the test doesn't apply, so I'm not going to bother. Next, what test should I use? Well, according to the suggestions that I gave you, this is a ratio of polynomials, so it can be compared to a p-series. So let's do some preliminary work to understand to which kind of p-series we want to compare to. So this will behave as the series where I only retain the highest powers. So in the numerator, I'm just going to retain n cubed. And in the denominator, n to the fourth. So this simplifies to 1 over n. So this is going to be the Bn that I'm going to compare to, and I already know that this series is divergent, so that's what I expect. It's divergent because it's a p-series with p equals 1, also called the harmonic series. Now, I could try to produce an estimate, but I think it would just be easier to do the limit comparison test, so let's go ahead. So what is this limit? The ratio of two fractions. So first of all, this is going to be this ratio will become the product times the reciprocal of 1 over n, which is just n. Okay, so then I'm just going to multiply that out. And you should be able to tell by now that this limit is just going to end up being 3, but let's do it formally. I'm going to factor out the highest powers. So here I take out an n to the fourth, so I'm left with a 3. From an n squared, I will be left with 1 over n squared. And from n, I will be left with 1 over n cubed. And then I do the same thing in the denominator, factor n to the fourth. So from here, I'm left with a 1, and from 5, I'm left with 5 over n to the fourth. Now I can simplify these two, and then I know that this term approaches 0, and this term approaches 0. So this ratio approaches 3 over 1, which is just 3. Well, so 3 is a finite number that's non-zero, not infinity. So the limit comparison test tells us that these two series have the same behavior. So since this is divergent, then our original series is going to be divergent by the limit comparison test. So divergent.